I'm Tom Swartz. I work at the Penn Manor School District. I've been flying multicopters, drones, for probably a better part of 6 months. On the low side, somewhere close to a year, maybe, if I had to guess. It's been a while. And I've really kind of dove into the subject, and if anybody watches the news, it's very much a big kind of hot topic discussion very recently. A lot of people are kind of pushing, both sides. Should we regulate them? Should we not regulate them? So I figured it would be a good chance to kind of describe, like what exactly are these things? Like how do they work? What exactly are we talking about when we want to regulate them or whatever? So let's get started. So first off, let's talk about some rules and regulations. As of yesterday, the rules are you have to stay below 400 feet. You have to stay below 400 feet. You have to keep line of sight with whatever you're flying. It can't be out over the horizon or something like that. If you're going to fly within a certain area of an airport, you have to make sure that you clear it with the tower. Otherwise, you might have airplanes that aren't very happy. So on and so forth. The only thing I want to point out here, keeping visual line of sight is kind of a gray area when people use goggles to fly first-person view. That's a really big burgeoning sport, I guess, recently. People will buy these little tiny, probably about the size of the multicopter here. They'll buy a tiny quad, and they'll race them really fast through trees or in through a parking garage or something like that. And they'll have a camera mounted on it, and they'll kind of play it like Battlefield style or something like that.
It's called pod racing, right?
Kind of like pod racing, exactly. So that's kind of a gray area because you have your goggles on and you can actually see where the quadcopter is flying, but you don't actually have line of sight to where the quadcopter is. So that's kind of something that a lot of people are kind of going to figure out. Don't put a gun on a drone.
You have to say it.
The kind of to extend and expand upon some of the rules, you have to make sure that you fly within those rules, and as long as you fly within those rules, you currently, like I said, as of yesterday, don't need special permission to kind of fly your quadcopter. As long as you're doing it recreationally, you're fine. If you're using it for a business, if you're using it for something else, it's no longer recreational, and you need what they call a Section 333 exemption, where you can fly something in United States airspace in order to work for your business. So when I talk about quadcopters and drones, this is what I'm talking about. Something that's kind of tiny, can be pretty small. Something like this. It can have 4, it could have 8 propellers. But you have to keep in mind when people talk about drones, they're also talking about something like this. They're huge. They can be very huge. They're very, very big. So just to kind of give the distinction, personally, there's no actual definition, but my personal definition is for a multicopter, it's something that you fly yourself. It doesn't have a lot of automatic control. It's something that hobbyist or a person just off the street would fly, and it's kind of small, very inexpensive, relatively, and it's easy to procure. A drone, however, in my definition, is something that a government would have. They cost millions of dollars. They're humongous. They could fire missiles and kill you. Something like that. So let's talk about some of the parts of a multicopter. And when I first got into the hobby, this is kind of something that I wish people had explained a little bit better. It's very much, at this point, since it's very new, it's kind of figured out as you go along. So to kind of go over some of the parts, you have what's called a flight controller. And on this guy, it's a very tiny circuit board here. They usually, what a flight controller does is it takes the inputs and converts them to a signal that the motors can then use to spin and keep itself level. Flight controllers can use GPS. They could use barometers to keep keep the device at a certain height and in a certain position. It can get very advanced and very expensive very quickly. But the most basic controller, like what's on here, basically just keeps it level and makes sure that all the motors are spinning the right speed. The next one is an electronic speed control. And what an ESC does is it takes the signals from your flight controller and converts it to three-phase to spin the motors. It'll spin it one direction. You can get an advanced ESC, which will take and allow you to spin the motors in two directions. So you can fly it this way, flip it upside down, and then spin the motors backwards to fly it upside down. Cut the grass if you want. Yeah. The motors, you can have brush motors like I have on here. They use little copper brushes and spin around on the inside to transfer the electricity. You can also have in-runners and out-runners. Those are actually brushless motors, and they're they spin a lot faster. They're a little bit more reliable for the purposes of multicopters. However, they don't give a lot of torque. So if you have really big propellers, they might run into problems if you have kind of cheap outrunner or in-runner motors. And last but not least, you have to have some sort of receiver and transmitter. On here, it's this little tiny red circuit board. Most of the devices use 2.4 gigahertz, which is Wi-Fi. You could get more advanced ones that go 5.8, and they have even more advanced ones, cough government, but they use satellite control. So you can bounce it off of a satellite and then kind of get it from anywhere in the world. So some basics about quadcopters and helicopters in general. So everybody knows what a regular helicopter looks like, but I don't think it's quite intuitive how an actual helicopter works. So you have, by conservation of momentum, the propeller on the top spins, and the body of the helicopter wants to spin the opposite way. You guys remember when you spin a tire, that physics thing, when you spin a tire and you stand on the platform and it spins? That's exactly what this is doing. So the propeller is spinning, and the body of the helicopter wants to spin the other way. The tail rotor, however, will help push or pull the end of the helicopter in the correct direction. That's kind of how it moves around. It's a lot more simple for a quadcopter, however. What they do is, rather than kind of balancing things like that, they just tip in the direction that they want to go. So you can have a roll, which is left or right. This is the front, by the way, the white ones. So you could do a roll, which is left or right. You could do pitch, which is up and down. You could do yaw, which is spinning left and right. And then you could do throttle, which makes it go faster. So in order to have stable flight, what the propellers do, just kind of like the helicopter example, they spin two pairs of motors at the same speed. So one pair will spin one direction, the other pair will spin the other direction. They kind of cancel each other out, conservation of momentum. If you want to pitch or roll, you'll spin one pair faster or slower so that it'll kind of wobble around that axis. And in order to yaw, to turn like this, just like a helicopter, you spin one really fast and it kind of pirouettes around that point. So that's the basics. It's obviously a lot more in-depth than that. It kind of goes in very deeply into control theory. I don't know if anybody's played around with industrial machines before or anything like that, but PID control is kind of a big kind of a big hot topic in industrial machines. It allows, basically what that means is it allows you to quickly and accurately get to the set point. So in terms of a quadcopter, what you could do is when your device is at a crazy angle, the PID control feedback loop will kind of help self-right it very quickly and with minimal calculations. So I'm going to show a practical example here. Let me get this all wired up and ready to go. So you have PID. PID stands for proportional integral derivative. The proportional term means that if the device is a certain proportion out of alignment, the controller will work in that proportion to bring it back. So I'm going to spin the motors up here. And you can kind of hear the motors working a little bit harder as I turn it. The integral term is a little bit more complicated. It takes into account how far out of alignment it is and for how long. So if it's sitting here stuck for a long time, it's going to gradually work a little bit harder to try and bring it back. So this works really well when you have a quadcopter that's getting blown in the wind. It'll try to fight back and go back against the wind. So you would have it, and it'll sit here, and you can hear it spin up. The derivative allows the flight controller to make sure that it doesn't actually overshoot where it's going. So it'll go from here, and when the proportional and integral work, it makes sure that it goes back to exactly here instead of back over here and have to repeat the cycle over and over. So I'm gonna wiggle this, and you'll hear it go wah wah wah. So you can hear that derivative function kind of coming in. And it makes for some very interesting and very neat flight. I'm going to try not to hit anybody here. Whoa! Whoa! So as you can see, it gets kind of, it's a little complicated.
How long have you been doing that? 6 days, what?
It's the air handling, so let's talk about it.
That light came out of nowhere.
That light came out of nowhere.
It hasn't been here a long time.
That's
So-
what it must be yesterday. Sometimes lights that low anyway.
Honestly. So yeah, as you can see, it kind of allows you to make sure that it doesn't end up flipping over, except when you hit a light.
What are the laws for flying these things indoors? I'm just kidding.
You can. You do whatever you want indoors. The FAA doesn't care. So as everybody was kind of chuckling, and as everybody probably heard, yesterday they kind of announced some new changes that are coming down the pipeline. They kind of announced that nothing's set in stone yet, but you might have to register whatever you get, be it something kind of cheap from Amazon like this that you got for $25, $30, to the big guys that you build yourself. Nobody really knows yet, but we'll kind of see on November 20th when they finally announce their actual changes. What's kind of exciting, however, is in this panel discussion, they're going to have a lot of really kind of high-profile folks from the quadcopter and flight and airline community kind of giving feedback on this as well. So it's not just going to be people are like, oh, I don't like these drones. So I'm kind of hopeful. I personally believe that it will kind of help crack down on the amount of knuckleheads that we have flying over the White House. I don't know why you would do that, but obviously people who break the rules should be kind of punished in some way. And this is, I think, a step in the right direction to help prevent them from doing something as silly as putting a gun on a quadcopter. So, thank you. Any questions? Yes.
So for the 5 mile rule, does that mean something even as small as that, that technically you should have to call the local airport and say, I'm planning to fly my literally hand-sized quadcopter?
It's very much a gray area. If you're going to stay below the tree line, you're probably okay. The main problems occur when people go out and they buy like a DJI Phantom, and they end up flying like a mile up in the air. They can't see it. It's behind the clouds, and airplanes are flying right by it. Things like that.
Okay.
As long as you're being reasonable, you're probably okay. I wouldn't be too concerned about it.
So does that mean you don't bother calling for permission locally?
Where I fly is not within the 5 mile radius, so I'm okay. But it probably wouldn't hurt if you're gonna. The closer you are, the more it kind of would be important to call. Like if you're gonna go stand right outside the airstrip, and probably that would be an idea to call them. But if you're just doing it in your backyard, staying below the trees, you're gonna be okay.
So you wouldn't bother if we walked outside? Then?
No.
Okay.
If I keep it in my backyard, am I allowed to strap a gun to it?
I don't know. That's a totally different area of expertise for
Like
me.
your neighbors do not like your neighbors.
I just want to hover in my yard, but outside my neighbor's window.
Wow, we put the gun on it.
No one heard that.
Is there a specific list of things you are and are not allowed to attach to these things? Like, I know you're allowed to put cameras on, but like, are they allowed to carry cargo on them?
Amazon.
Or is that not?
You can. I mean, the cargo part kind of falls into the line of sight issue.
Uh-huh.
So when Amazon takes their drone and they fly it, 6 miles away from their spot, obviously they can't see it anymore.
Yeah.
So, that's not within the law anymore. However, you can, if you want, you could put, like those little army men on parachutes, take them up and drop them down if you want. It's totally fine. Whatever you want to do.
Are there any groups that have formed around applied uses or interest groups like citizen science looking for new archaeological sites or doing laser scan, 3D mapping of cave sites, for instance?
That's actually a really interesting question, and there's a ton of groups that have popped up that do exactly things of that sort. There are a couple people that do crop mapping, so they'll fly over fields and kind of make sure, okay, the corn here looks good, the soybeans here look okay. What's that weird thing looking there? Is somebody planting weed in mine? Things like that. I've seen some groups, they have really crazily designed multicopters, and they're hoping to use them for firefighting. So they'll fly and they'll use some special mixtures of it's kind of like basically a hovering fire extinguisher. So it'll come out, if your car's on fire, it'll fly out real quick, douse your car and fly back. So there's a lot of really, really interesting and novel ideas that are kind of popping up. And personally, I think the biggest concern is with people not kind of abiding by the law, it's going to kind of squelch this interesting development coming out here.
The slide you had on there for PID or whatever that was talking about the sort of different approaches to solving common problems or whatever. Anyway, are those each one of those things I could kind of see how there'd be different physical approaches, different algorithms almost that you could use to solve them. You had mentioned that this quadcopter with the derivative part. In order to solve the problem of going too far, it just kind of wobbles back and forth until it stabilizes. But I could also imagine there could be an approach of acceleration and then deceleration as you start getting to the point, so it almost lands perfectly. Is that the type of, do you have any option in like sort of recreational drones to like program that and play around with those types of algorithms?
You do, not for the inexpensive ones like this. However, I have a kind of bigger one. I didn't want to bring it because it's really scary looking, and I know there's not a lot of room here. I had a little trouble with this one, so you can only imagine. Anyway, but with the bigger ones, they have more advanced flight controllers that you could program pretty much anything you want. Yeah, so they're really kind of customizable in that way.
Cool.
And when you change all those settings, it could take totally different flight characteristics.
Yeah.
So you could kind of dial it in so it's really smooth, really stable, or you could also kind of bump the numbers up so it's real quick and real maneuverable for racing, for example.
Cool.
Is there any thought on whether there will be a fee associated with registration, or and like it kind of as a follow up, is there like any guidance from the government's position on this, that they're trying to disincentivize people from entering this as a hobby? Or
I haven't heard of any fees or anything, any discussion of that sort yet. However, the government seems to want to encourage this very much because they kind of see that you have the practical applications, not just people being silly and flying into a Boeing. So it was probably around April, I guess, they had announced preliminary instructions. Those are the ones that I had up very early on in the slides. Those are some of the regulations that they proposed back in April. Up until that point, you were basically kind of only limited by whatever the American Model Association, basically RC groups, had proposed for rules and regulations. So this is the actual first time in forever, honestly, that there's actual government intervention in this sort of thing.
What's the protocol for like uniquely identifying the signals, like for transmitting and receiving flight control?
Each transmitter has a unique pattern. For example, a lot of them, the one that I use, my big hobby style, they use frequency hopping and things like that, and they have a specific bind method that you have to use, and that kind of matches the frequency hopping pattern to that receiver. So you can have multiple devices on the same frequency kind of working at the same time. Previously, they used to use, when you would go to an RC, certified RC airfield, you'd have to get a crystal oscillator, and they would give you a crystal oscillator that you would put into your remote, and that would be your frequency for your device.
That is awesome.
Working with crystals, not so scientific, but it used to be very rudimentary, but now with kind of ICs and making it all digital, it's very, very precise and interesting.
Has anyone tried to do a cellular connection from receiver to transceiver?
They have, yes. I didn't mention those. There's a whole slew of different types of connections that you can use. Cell connection's one of them. They also have, it's kind of like the Ubiquiti wireless. It's like very long range point-to-point stuff. A lot of people who use that, not specifically with multicopters, but they'll use it for airplanes where they can fly, maybe about half of a mile out down a field or something like that, and still have a signal. So, yes.
Is there a limit to the size a person can have?
55 pounds seems to be the current limit. If you're anything larger than that, you have to file for some sort of actual aircraft certification. But honestly, if you're more than 55 pounds, you're probably pretty huge and you could carry the associated equipment anyway. So, yeah.
Let me just remark on, no one should be putting guns on these things, but can you imagine, like, so much effort had to go into this. Not only do you have to, like, figure
It
out.
looks like a lot of tape though.
It's a lot of duct tape. A lot of duct tape.
Getting the gun on there is the easy part. Like you have to not only rig something up to pull the trigger, the whole quadcopter needs to absorb the shock.
If you watch the actual video, every time it shoots, it like almost slips backwards.
But it doesn't.
So they
But
did.
it almost does.
It's
Like
onboard logic.
it's definitely not. It's not.
Yeah, that's the magic of the PIDs. It's the PIDs that keep it.
I'm imagining how out of control the shotgun was pointing at you.
I was thinking, for 55 pounds, I mean, shotgun might weigh like 115.
No,
Like, you could put a shotgun on one of
I'm
those
intrigued,
things.
like, I'm intrigued about, like, I guess, what you would need to do to, like, a quadcopter to actually program it to more intelligently absorb the shock of a gunshot. That would be crazy.
Fly into it almost.
Like, almost like every time you pull the trigger, you have to, like, ramp
Gun
up
it.
your pitch, but you can't
Like,
do it
literally
too much,
gun
'cause
it.
you don't shoot it.
I'm sure Boeing would love your input on that.
This is a wonderful presentation.
I wrote this algorithm so you can shoot a gun that doesn't move at all.
So,
They're all gonna figure
just to
this
kind of
out.
bring it back, everybody seems to have seems to be interested in the destruction part. Why not? If you're really interested in that, however, look up online. There's a group called Game of Drones. They make quote unquote indestructible quadcopters, and they have competitions where they fly them and battle them, kind of like battle bots. Kind of like battle bots. So the whole point is to try and see who has the most rugged and indestructible quadcopter. So definitely check it out if you're interested in that sort of thing.